The topic for today is electrode potentials and electrochemical cell. Electrochemical cell is a device by which chemical energy is converted to electrical energy. You're welcome. Standard electrode potential of a metal-ion metal system is the potential difference set up between the metal and a 1 molar solution of its ions at 25 degrees Celsius. Arbitrarily, taking the standard electrode potentials of hydrogen ion hydrogen gas system as 0 volt. Hydrogen has been chosen as an arbitrary standard with an electrode potential value of 0 at all temperatures. Measurement. The metal-ion metal system or half cell is connected to the hydrogen ion hydrogen gas system or half cell by a salt bridge. The potential difference between the two half cells is known as electromotive force or EMF. Electrons flow from hydrogen to copper. Looking at the diagram below, hence the electrode potential of copper is positive. The diagram describes the use of hydrogen as arbitrary standard in measuring the standard electrode potential of copper. Standard electrode potentials of some common metal-ion metal system are represented below: potassium ion, calcium ion, sodium ion, magnesium ion, aluminium ion, zinc ion, iron, lead ion, hydrogen ion, copper ion, silver ion. Electrochemical cell. This is also called galvanic cell or voltaic cell. This is a device in which chemical energy is converted to electrical energy. A flow of electrons can be set up between two electrons which have different electrode potentials. The higher the difference between the two electrode potentials, the higher the speed of electron flow. It contains two half cells. When metallic zinc is in contact with zinc ion and metallic copper, oxidation occurs at the zinc electrode, being the anode. The atom at zinc electrodes lose 2 electrons and go into solution. The zinc electrode becomes negatively charged. The excess electron will flow through the wire to copper electrode. The copper 2 ion takes up the electron and becomes reduced to form metallic copper. The copper electrode becomes positively charged, that is, the cathode. Anode, zinc, going into zinc aqueous plus 2 electron, oxidation. Cathode, copper 2 ion plus 2 electron, going into copper, reduction. The anode becomes depleted while the cathode increases in size. Net reaction is zinc solid plus copper 2 aqueous going into zinc 2 plus aqueous plus copper solid. Salt bridge. A salt bridge connects the two half cells. It can be made up of filter paper soaked in sodium chloride or potassium chloride or ammonium trioxonitrate 5 solutions. It completes the electric circuit and enables the movement of ions flow from one half cell to the other in order to maintain electrical neutrality when current flows. EMF of cell, E naught cell, is the difference between the right hand side electropotential E naught R and the left hand side electropotential E naught L. E naught cell is equals to E naught reduction minus E naught oxidation. Zinc into zinc ion, a salt bridge, copper 2 ion plus copper. If the E0 cell is positive, then the reaction will be spontaneous. If negative, it will not be spontaneous. Zinc going into zinc ion plus electron. E0 equals to minus 0.763 volts. Copper 2 ion going into copper. E0 equals to positive 0.337 volts. E0 cell equals to E0 reduction minus E0 oxidation. E0 cell is equals to bracket plus 0.337 minus 0.763 bracket close volt equals to plus 0.337 plus 0.763, which is equals to 1.1 volt positive. It will be spontaneous. Exercise 1. The function of zinc electrode in galvanic cell is that it A. undergoes reduction, B. serves as the positive electrode, C. produces electrons, and D. uses up electrons. The correct answer is C. produces electron, because the zinc electrode produces the electron that flows towards the copper electrode. Exercise 2. The major function of saw bridge in cell is to A. smoothen the electron flow, B. to provide electricity, C. to complete the electric circuit, and D. to provide adequate driving force. The correct answer is C. to complete the electric circuit. Exercise 3. The reaction that takes place in a Daniell cell is A. direct combination, B. redox, C. double decomposition, and D. neutralization. The correct answer is B. redox, because there is oxidation and there is a reduction have reaction in electrochemical cell.